Okay, welcome back again to JB Teguihanon Engineering and Chemistry tutorial. Let's continue our study refrigeration systems. We are reviewing the basic concepts. In the last video, I had discussed the density. Okay, density is what is density? Density is mass per unit volume. That means your density, if the symbol of density is like this, density is mass over volume, right? V. But sometimes density is expressed in a specific volume. Okay, specific volume, or this guy here. This is the symbol of specific volume, and this is volume or volume per unit mass. Volume per unit mass means this guy here, that's small v, is equal to volume per unit mass. So in other words, the reciprocal or 1 over density, the reciprocal of density. Okay, so this is what these things is all about, right? So don't be confused with that. Density is mass per unit volume. Specific volume is volume per or divided by mass. Okay, that's the difference. So in other words, your then specific volume is the reciprocal or the inverse of your density. So that is the difference between the density and the specific volume. Specific volume symbol is small v. Okay, and the density symbol is like this, right? This guy here. Okay, that is density. And this guy here is specific volume. Okay, now let's go to the density associated with mass. Density is weight density or specific weight. So we have another term here which is called specific or specific weight or weight density. So weight density is this guy here is equal to the weight over what? Volume is V. Okay, and the unit is Newton per cubic feet, and this is in terms of density and gravitational acceleration G. This is the form or the formula. We call it specific weight. Okay, the unit here is in Newton per cubic meter. So, meaning to say the basic formula is weight. Again, weight. This is weight, right? In Newton over volume. The unit is in cubic meter. So this is the formula, basic formula. And this is a variation formula in terms of density and in terms of gravitational acceleration. So meaning if you are asked to solve for the specific weight, okay, this is the specific weight, but no weight is given, no volume is given, but you have density, okay, which is this guy here, the density is given, and G is given, then you can solve for specific weight. Okay? Okay, let's move on then. So, to reinforce our topic, we have to see a example here. Okay, for a normal, for a normal, sorry, for water, the normal value of your density is 1000 kilogram per cubic meter in SI unit, right? System International. And for English system, you have 62.4 pound mass per cubic feet. That's for the density. For the specific weight, for this guy here, that is specific weight. The normal value of water is 9810 Newton per cubic meter. 9, but actually we are memorizing this as 9.81, 81 kilonewton per cubic meter. Kilo N, that is Newton. Okay, kilonewton per cubic meter. Okay, let's continue. I have a hard time writing it down. And then for air at sea level, for air at sea level, the value is uh, 1.21 kilogram per cubic meter. So actually, you can use this in solving if you are dealing with the fluid machineries, right? Like pumps, you can use the uh, density of water. If you're looking for the power of the pump, okay. If you're dealing with fan, you will be using this density of air, right? So for now, just be satisfied with that and just continue to keep learning and memorizing it. Okay, remembering it. Store it in your mind. Okay, and of course, you have also in English. You have this This is the specific weight of, sorry, the density of air, 0.0755 pound per square feet. But the technique here is just remember the one system for both water and air. And the easy thing to remember is in SI unit. So remember the density of water, that is 1000 kilogram per cubic meter in SI. And then the density of air at normal sea level at normal condition is 1.21 kilogram per cubic meter. This is in cubic meter. This guy here. Okay, and I'm just discussing it for the sake of lecture. Okay, so let's put it in an example. We have here an example. So example 1.5, the mass of air is talking about the mass of air here. Mass of air is the mass of air in a room 3 by 5 by 20 meter is known to be 350 kilogram. It's talking about air. Determine the density, means rho. This is rho and density. Okay, and then the specific volume, and then the specific weight. There are three specific uh, there are three unknowns here that he wants you to determine, that is density, specific volume, specific weight. So let's jump in and calculate this guy here. Okay, so density is equal to mass. Okay, I changed the color of my phone. So density is this guy, mass over volume. So what's the mass? The mass is 350 right here. So plug in, what's the volume? Plug in this volume here, this dimension. The volume is a three-dimensional, that is actually a space, that is height, length, width, and height, right? So plug in the value, perform numerical calculation. You have 1.167 kilogram per cubic meter. And that is your density, because density is mass, that is in kilogram over volume. Volume is in cubic meter. So the next question is, what is this specific volume? So specific volume actually is expressed. Now the basic formula is volume or weight over volume. But if it is not given, this one is not given, you will use this formula, density times gravitational acceleration. Okay, what is the density of your air? So the density of air is, you have already calculated, 1.167. And what is G? G is standard, right? Standard right here. It says that right? So the mass of air determine the density or specific volume, and the specific volume is this guy here. Okay, so I think it's, you can hardly see the, so here is the specific, uh, I'm talking about specific volume here. So specific volume, this is the guy here. Okay, this is just the reciprocal of density. It's very easy. Once you have this, plug into this formula, 1 over density, that is your specific volume. Okay, and then the third one is specific weight. Specific weight is this formula. Okay, density times G. Your density is 1.167 already. That's calculated, times this guy here. This is the gravitational acceleration, G, at SI unit. That is 9.81. Okay, and plug in and perform numerical calculation. You have this guy here. Okay, so that's all for now. Thanks for watching. Please subscribe. JBTeguihanon Engineering and Chemistry Tutorial. Thanks for watching again. Bye.